So good evening everyone. Welcome to this Marine Edge. Okay. So today I'm your tutor Kusham Kaushik. I had secured an IMU-CET rank of 151 in my 2023 examinations. Okay. So today I'm here to guide you with these mind maps for your mathematics syllabus. Okay. So what this will help you to do is that it will help you to understand your concepts better. And if you have a great preparation, you will get a better side of revision. Also, if you may have missed some topics which are very important for the sake of this examinations, you may get another chance to see them or to see how well they can be used for your examination preparations. Okay, so without wasting any time, let us start with the mind map series for IMUCT. Okay, so with the first chapter that we'll start is that we'll start with class 11th portion. Okay, so we'll start with relations and sets. Okay, so I hope that everybody of you is familiar with the term sets. Okay, so if I were to write a set, okay, so a set looks something like this, that if this is a set signifying the first five natural numbers, so this will look something like this. Yes or no? Okay, so what I'll do is that I will try to define a relation so that whenever I mean to say that something is related to another, what I say is that every element of this set will be related to the other element of this other set. Okay, just say that I have branched this one with 2, one with 3, one with 4, and one with 5, and one with 6. Upon doing this, I can actually see that I have now signified a relation between 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Yes. Okay, so this is what is called as a relation. Okay, so mind you that we have seen that the first set has some elements, that is the total number of elements is this in this set 1 is m, and for the second set the number of elements is n. So the total number of relations, that is the total number of relations which can be defined, will be 2mn minus 1, which is also written here. Okay. 2mn minus 1. Okay. So like domain and range, you can actually see that out of these 1, 2, 3, 4, 5, and for the second set which has n elements 2, 3, 4, 5, and 6. Okay. What I've actually done is that I have taken one set through which I have defined the relation to the other set. That is, this one is actually your input and this two is actually your output. Okay. So what we say is that this one will be your pre-image. This two will be your image. Okay. So what you can actually say that this two is the image of element one. This three is the image of element one also again, and this four is also the image of element one. So I think this was clear about image and pre-image. Okay, domain is something that we take as the input. So one was taken as the input, and we got two as the output. So two will be what, the range. Okay, so if I want to define this set actually in the terms of domain and range, the domain will be one, while will the range will be 2, 3, 4, 5, 6. Okay, so this was all about domain and range. Now we are moving to relations as well as functions. Okay, so functions is more important as compared to relations. Okay, so you have actually seen that yes, that if I have now defined this relation of 2, 3, 5, 7, which is in this case actually 2, 4, 7. Okay, so let us call this set as A, and let us call the second set as B. Okay, so first of all, what I've done is that I have defined the relation from A to B. Okay. Okay, so this was defined from A to B. R is defined from A to B. So now what I'll do is that I will take the inverse. Inverse means what? That I'll invert the things. Meaning that now I'll say that I will define these relations from R inverse, that is, I'll define these relations now from B to A. Is that clear, every one of you? So now what happens is that what was the domain in the first case will become the second case range, and what was the range for the first case will be becoming the domain for the second case. Okay, you can actually see that A is the domain for the first case, while A is the range for the second case, B is the range for the first case, while now we have B as the domain of the second case. Okay, so I think this should be clear. Identity relation defined in a set is said to be identity relation if every element of A is related to itself and only to itself. Okay, so if you have set A, okay, 1, 2, 3, 4, 5. Okay, so if I have a set which looks something like 1 comma 1, 2 comma 2, 3 comma 3, and also we can have elements like 4 comma 4 and 5 comma 5. So what you can actually see is that 1 is only related to 1, 2 is only related to 2 and 3 is only related to 3, while they are not related to any other element. Okay, so like reflexive relation can be defined in such a way that you can actually say that these identity relations as well as reflexive relations are interrelated. What I can actually mean by saying is that if I have 1 2 3, okay, so identity relations will look something like this: 1 1 and 2 2. Okay, 1 1 and 2 2 will be the identity relations. But what if we have these identity relations for all the three elements of this set? That is, it looks something like 1 comma 1, 2 comma 2, and 3 comma 3. Okay, so what this actually helps us to see is that now we have a relation, or we have a set of relations: 1 comma 1, 2 comma 2, and 3 comma 3. So what is this? This is a reflexive relation because we have an independent identity relation for each and every element of this given set: 1 2 3. Okay, symmetric relation is also very similar. That is, if I have 1 2 3, we will take the same set now. If I have 1 2, okay, and I have 2 1, and I have 1 3, and I have 3 1, and I have, okay, so I can take this as, yeah. Yes, okay. So what I can actually see that I have 1 2 and I have 2 1. I have 1 3 and I have 3 1. So what you can actually see is that 1 2 is symmetric to 2 1 and 1 3 is also symmetric to 3 1. Okay. So in this way we can actually see that these relations are what? They are symmetric to each other. Okay. So now for the second topic we will see the third topic, that is we will see transitive relations. So that if you have 1 2 3, you have 1 2, you have 2 3, you have 1 3, you have 3 1. Okay, so if I were to say that this is relation a comma b, so then this is b comma c. Yeah, and this is, if it is a comma c, so then this is c comma a. So what this actually helps you to understand is that a relation can be transitive, okay, when we have the elements a comma b as well as b comma c and a c and ca, okay, which is defined here. That is, a comma b belongs to r and b comma c belongs to r, then a c belongs to r. So this is what you have for transitive relations. And equivalence reaction can be same, that if all the three conditions are being satisfied by this function, for odd function or the relation that you have actually defined. Okay, antisymmetric relations, a relation R is said to be antisymmetric if a and b belongs to r and b comma a belongs to r, then a must be equal to b. Okay, a must be equal to b, then you can have that this is a special case for reflexive action relation, something similar to that. That is, if it is 1 comma 1, then it should be 1 comma 1 also. That is, only in these cases you can actually see that this can be an anti-symmetric relation. Okay, so now we have the types of function. Mostly we have the greatest integer function. Greatest integer function is also of very utmost importance for us. That is, if I want to talk about the greatest integer function, okay, so if I have a number 4.5, okay, if I have a number 4.5, so what I'll actually do is that I can divide this between 4 and 0.5. Yes or no? I can do this. Okay, so what I've done is that I will now resolve it to the closest integer that it will have, that is 4.5, though it is closer to both 5 and 4 equally, that is, it is 4.5, but we'll choose 4 in this case. So this will be the answer for 4.5, and it is denoted in a way 4.5. Greatest integer is this. This is how you define a greatest integer function. Okay, so fractional part function is also this very same. Okay, fractional part function for cases, that is, if you have a fractional part function of 4.5, let us take for both these cases. Okay, 4.5. Okay, if you have 4.5 actually, and now I want to define the fractional part function for this. So you can see that this 4 is also 4.0 plus 0.5. Yes or no? You have 4.0 and 0.5. Okay, so when I'll have to resolve this, you'll actually have to see that for every function we have the fractional range between 0 to 1. Yes, yes, because अगर 1 से ज्यादा हो जाएगा या 1 से कम हो जाएगा तब तो पूरा इंटीजर बन जाएगा, और हमें चाहिए फ्रैक्शनल पार्ट. ओके, फ्रैक्शनल पार्ट के केस में क्या होता है कि इट शुड ऑलवेज बी 0 or equal to, it should be either between 0 or 1. Okay, yes, is that clear, every one of you? So this is how we define a fractional part function. Identity function, that is, if a function is defined from fa to a, defined by fx is equals to x for all x belongs to a, then the identity a is denoted by ia. It is easy to observe that identity function is defined by this. Okay, constant function. constant function if a to b is said to be constant function if for every element of a has the same image in b. That is, which we if you guys remember, we talked about the first example actually. If you have 1 2 3 4, okay, and this is also 5 5 and 5, okay. So if I have this, you can actually see that 1 is also projected to 5, 2 is also projected to 5, okay, 3 is also projected to 5, and 4 is also projected to 5. So you can actually see that 1 comma 5, 2 comma 5, 3 comma 5, and 4 comma 5. This is how actually you will see this. That is, now you are actually seeing that this is a constant function because for every element of set A, B is having what? B is having the very same image. That is 1 to 5, 2 to 5, 3 to 5, and 4 to 5. That is what you can actually understand from this. Okay. So we have already talked about the range. That is, range is basically what? This is the output. Okay. This is the output for a given function. Okay. Equal identical functions, two functions can be said to be equal or identical when they have what? The basic properties of functions as same. That is, we are talking about domain as well as range. So when the domain is equals to the of the first function is equals to the domain of the second function, that is when the range of the first function is also equal to the second function, you can actually see that say that these functions are equal or identical. Okay. Also, fx and gx, that is the function, the values of those functions at each and every x belonging to their common domain. That is because if they will share the same domain, that is, they will have this common domain for them. Okay. And if every for every value of fx and gx in that domain, if that value is equal, we can say that these two functions are equal or identical. Okay. So we are now talking about one functions as well as your onto functions. Okay. So one, as the name signifies, which looks something like this, that is one, that is one element is mapped to only one. So you can actually see that 1 is only mapped to 1, which is in this case, that is 1 is mapped to 1, 2 is mapped to the second element of the second set, 3 is mapped to the third element of the third set. Okay, so this is a 1 mapping. Okay, mind you that for many one mapping, you have many 1, that is many are mapped to 1. You can actually see that 1 is mapped to 2, 1 is mapped to one element. Now let me draw this, that is, this is now mapped to 2, and this is now mapped to 3 again. So you can actually see that 1 is also mapped to 2 and 3, 2 is also mapped to 1, and while 3 is only mapped to 3 only. So you can actually see that there are many and many projections for a single element. Okay, so this was about many one functions. Now we'll move to some understanding what are one as well as your onto functions. Okay, so just, yeah, one into and as well as your onto functions. Into functions are what? Like if you have 1 2 3 and you have 1 2 3 4 elements here. Okay, so if I'm now mapping this, no matter I'm mapping this in the sake of many one functions or one functions. Okay, if it is mapped to something like this. Okay, so this is actually, you can see, let us take another element inside. Okay, so this is now having at least 5 elements now. So upon having 5 elements, you can actually see that this element is actually left behind, that this element has not been mapped to any element from the set A. So what this will actually show us, that this is an example of into mapping. That is, this is a into function where the not all the elements of the range are mapped as compared to the domain. Okay, and when we are talking about onto functions mein kya hoga ki that every element will be mapped with each other. Okay, that is, no element from the domain as well as the range will be left behind. So you can actually understand this by this saying that what is a many one function and what is a one function and what is an into function and an onto function. Is that clear, every one of you? So we'll now move towards the composite function. Okay, so composite functions, I think everybody of you must have studied f of g and g of f. Okay, so let us take an example of f function as x square and gx as sine x. Sorry, I think this might be obstructing the view. Okay, so let me take this on the other side. Okay, so see that, that is, if you have fx is equals to x square and gx is equals to sine x. Okay, so what will be the value of f of g? F of g, this will be sine x square. That is, sine x has been taken as an input in x square. Okay, and what is g of f? G of f, that is, instead of taking x sin x, you will take the value of x as x square since it is g of f. That is, g will be taking the input of f. Okay. So now this is sine x square. I think this is clear to every one of you. Yes. Now we are talking about the homogeneous function. That is, the function can be said to be homogeneous with respect to any set of variables when each of its term is the same degree with the respect to those. I think this is very clear to every one of you. Bounded functions. If you have a function which looks something like this, that is, if you have a function like this, and I have now bounded this. That is, now I have made sure that this function cannot extend big across these boundaries. So now I have kind of bounded these functions across the x-axis as well as across the y-axis. So this is how the boundation is done across the y-axis, and this is how you have bounded this function around the x-axis. So this is the area which will be giving you the value of the function, that is the bounded function in this case. Okay. An implicit function and explicit function. A function which is defined by an equation and not solved by the dependent value is called as an implicit function. And now, similarly, explicit function can be defined as a function which can be defined by an equation and can be solved by the dependent variable is called as an explicit function. For example, x square y plus y is equals to 1. Okay. So in this question, you can see that for any values you can try, because now we have the number of variables as 2 while we have only a single equation. So that means that we cannot solve this. Okay. We cannot solve this. Now when I have done this, that is when I have taken y as common, x square plus 1 is equals to 1. So now you can actually see that the value of y is 1 upon x square plus 1. So you can actually see that the value of y is now dependent on x. So which means that you have actually solved this. That is, now you have represented y in terms of x. Okay. So implicit and explicit functions are not exactly some different functions. They are just differing in the way in which you are solving them, or they are and how you are actually expressing those functions. Okay. So you can actually see in this case, that is x square y plus y is equals to 1 was an implicit function, while y is equals to x square plus 1 was an explicit function. Is that clear, every one of you? Okay, so now we'll move towards odd functions as well as your even functions. Odd functions are what? Let us say that I am taking an example of x square, that is fx is equals to x square. So you can actually see that when I'm taking the input as positive or negative, I'm getting the very same output. That is, if I'm taking f minus 1, still I'll get 1, and f1 will be 1 anyways. Okay, you can actually see that for the values of the same function, and I have changed the sign only for the input, that is f minus 1 and f1. So they are only differing in the way of writing the sign, that is minus and positive plus. Okay. So what is actually happening is that for an even function, these outputs will remain the same. But now when I'm talking about f x is equals to x cube, and I'm taking the very same out inputs now, f minus 1 and f1. So you can actually see that this is now equals to minus 1 and this is actually equals to 1 only. Okay. So in this case, the both of the outputs are not the same. So you are saying that this is an example of an odd function. Yes, is that clear? So now we'll move towards the other topics. That is, a function may neither be odd nor be even. Okay, the inverse of an even function can be not be defined, and an even function cannot be strictly monotonic. Monotonicity will be something which we'll be studying a little later. Okay, of every function can be expressed as a sum of an odd and an even function. Yes, for sure. That is, if I have a function x to the power 3 plus x square by 5. Okay, so can I not express this as something like this, that is x cubed by 5 and x square by 5? Yes, because this function in the numerator, you can actually see that the denominator is what? The denominator is a constant. So obviously, this constant will have no impact on the even and odd nature of the given function. Yes, so we'll say that we can actually express every function as the sum of an even as well as an odd function. Yes, so now we'll move towards this table. So this table is something that you'll have to memorize. Okay, this is an important table, and maybe some questions can be asked in the DNA sponsorship exams or as well as in your main IMU-CET exam regarding this topic. Okay, yeah. So the inverse of a function, we have already studied that. The properties of a inverse of a bijection is unique. So let me tell you what is a bijection. So like we have studied, so if a function is 1 1 as well as on 2. Okay. So when a function is one function as well as an onto function, in that case you can actually say that the given function is actually a bijection. Okay, so I hope that you guys were able to understand this, that if a to b is a bijection and b to a is an inverse of f, then f of g is equals to I and g of f is equals to ia, when where ia and ib are the identical functions on set a and set b respectively. Okay, so you have to just read across these statements actually. A periodic function क्या होता है? So you can actually understand by the term that is periodic. That is, it is talking about a period. So what is actually happening is that you can actually comprehend this by using the graph of sin x. Yes, I think everybody of you remember this graph, or you should remember this graph actually. You can actually see that the value of sin x starts from 0, okay? You can actually see that it returns to 0 after these two bumps, okay? So what is actually it is actually happening is that the value of sine is actually repeating after 2 pi. You should know that the area of this given bump is what? It is equals to pi, and the area is, and the value of this given function is actually repeating after 2 pi times. So this is 0 to 0 and this is 2 pi. Okay, so this is actually the period of this given function, that is 2 pi is the period of the given function sin x. Okay, so you can actually calculate the periods for every thing, that is we will study it out a little later about this. Okay, the period properties of a periodic function, ft is equals to f0 f minus t, where t is the period. The inverse of a periodic function does not exist, that is you cannot take the inverse of a periodic function. Every constant function is always periodic with no fundamental period, that is 5 will be equals to 5 no matter how many times you are talking about it. Okay, 5 after any period will be 5. Yes sir, this should be a common knowledge. If fx has a period p, then 1 upon fx and under root fx also has a period p. If fx has a period t, then fx is equals to f a x plus b has a period t upon a. So let us say that you have an example of fx is equals to sin x, sin 2x actually, sin 2x, and the period of sin 2 and the period of sin x is what? It is 2 pi. Okay, so in order to find the period of fp, that is period of fx, okay, it will be 2 pi divided by 2. So this is actually pi. So what you have actually seen is that now we have divided 2 pi with the coefficients of x which was present in sin 2x. Okay. So now we have got the period as 2 pi divided by 2. That is the period for sin 2x is what? It is equals to pi. Yes, is that clear everyone of you? So now we'll be moving towards a little move further forward. That is the transformation of a graph. Okay. So transformation of graphs is something that you should take a good glimpse of. This is presented to you right here and just take a good glimpse of it. I hope that you guys can understand using this only. Okay, so now we'll move forward towards trigonometric functions. Okay, trigonometric functions, I think everybody is familiar with sin x, cos x, tan x, and cot x. Okay, so sin x and cos x are the basic fundamental creators of trigonometry. That is, any function can be created using these two functions. Okay, so now you have to understand about the general solution. That is how we are actually finding out the solution of a given equation which has the sin x variable. Okay, so the general equation has x is equals to n pi. The principal solution in 0 to 2 pi, x is equals to 0 to pi. Principal solution in 0 to 5 pi, x is equals to 0, 2 pi, 3 pi, 4 pi. Okay, the general solution of cos 0 is ठीक है. So this is how you can actually understand the general equation of some trigonometric equations. That is, the general solution of sine theta is equals to sine alpha, where theta is the known angle and is assumed to be in radians, while alpha is the known angle. Okay, so these are the some properties that you can actually go through. ठीक है, these are the properties that you can actually go through, or you can take a good glimpse of this through our marathon lectures that are presented on our app. Okay. Okay, so you will see the general solutions for all these variables, all these trigonometry functions. The equation sec 0 is equals to sec alpha is equivalent to cos A is equals to cos alpha. So mind you that not for every question in IMUCET will be regarding this general solution. So general solutions are not something that you are very important to deal with. Okay, these are not actually very important for the sake of your examination. Okay, now we are moving towards inverse trigonometric functions. Inverse trigonometric functions we can actually see, that is, they are what? If I want to say that the value of sin 60 degree is equals to pi by 3, okay, अगर हम कहना चाह रहे हैं कि sin 60 डिग्री की वैल्यू pi by 3 होगी, नहीं sorry sin 60, sorry I'm really sorry for this, just wait a minute. If I'm saying that sin 60 degree इज इक्वल्स टू रूट थ्री बाई टू। ओके, मतलब साइंस जब 60 डिग्री है तो उसकी वैल्यू 3/2 है। तो हम इसको दूसरे तरीके से नहीं पढ़ सकते, दैट इज वी कैन वी नॉट स्टडी दिस इन द अदर वे, दैट इज साइन इनवर्स 3/√3/2, that is at if I have the value of sin x as √3/2, then what should be the corresponding value of theta? Okay, we can understand this in this way also. This is what is understood by the help of inverse trigonometry functions. Okay, so you can actually see that sin inverse x, the domain is between -1 to 1, -1 to 1. For both the cases, cosine inverse x as well as the cos inverse x, the range is between -pi/2 to pi/2 for sin x, and it is between 0 to pi for cos inverse x. For tan inverse x, you will have -pi/2 to pi/2 as your range. Okay, and you can see all these ranges present in the table. Okay, so this table is very peculiarly important for you guys for the sake of IMU-CET exam, for because most of the times they can ask you direct questions regarding these. Okay, they won't even ask you about different domains. They will just ask you about the domain as well as the range for tan inverse x, and you'll have to answer it. Okay, so the graph for the six inverse circular functions. Okay, so these are the functions we are talking about, and you can take a good glimpse at their graphs. Okay, and also you should know that it is a bounded function, and which is the most important thing according to me is that whether you have to understand that the given sine inverse function is an odd function or an even function. So you have already studied that the given function of sine inverse x is always an odd function. Okay, that is symmetric about the origin. Okay, and also you should know that the cos inverse function is neither even nor odd. That is, we had studied a case before that when we were given a bullet point which mentioned that a given function can neither be even nor odd. Okay, so for tan inverse x, you should know that tan inverse x is an odd function. That is, you can actually see this from here. It is also aperiodic and it is a continuous function. Cos inverse x, cos inverse x के case में you can also see that. Okay, cos inverse x is also an important function, that it is also a monotonically decreasing function. It is an aperiodic function. It is also a bounded function, and it is an odd function also at the very same time. Okay, so this is what you can revise through the natures of inverse trigonometric functions. This is an important slide for you guys. Okay, and this is now sine of sine inverse x. That is, we have taken an inverse function, and now we are taking the sine function. That is, we are now defining a trigonometric function for the inverse values, that is sine of sine inverse x is equals to x, the cos of cos inverse x is actually equals to x, the value of tan inverse x is also equals to x, and the value of y cot of cot inverse x is also equals to x. So this is what you can actually understand from this table. Okay, so these are few identities. I hope you guys are familiar with these identities. These identities are the most important building blocks of inverse trigonometry as well as your trigonometry. Okay, so just go through these properties. That is sine inverse minus x is equals to minus sine inverse x. Mind you that sine x and sine inverse x both are odd functions. Okay, and cos x and cos inverse x both are what? They are even function. That is, both are even. Okay, is that clear? So you have to understand this. That is, tan is also an example of an odd function. Cos is an even function. Cot is also an even function. Okay, so this is how you can actually understand this. Okay. Now, these three properties are the very important properties for the sake of your examination. That is, sine inverse x plus cos inverse x is equals to pi by 2. Tan inverse x plus cot inverse x is equals to pi by 2. Cosec inverse x plus sec inverse x is equals to pi by 2 also. Okay. Inverse trigonometry functions. ठीक है, यहाँ पे आपको दे रखे हैं. ठीक है, एफ एक्स इज इक्वल्स टू कॉस इनवर्स 1 minus x square upon 1 plus x square. Okay, so what you have actually done is that cos inverse x के केस में 1 minus x square and 1 plus x square. Okay, so what you will do is that you will have to understand that this function is further resolved into minus 2 tan inverse x and 2 tan inverse x. Okay, so this is how you will actually understand this. That is tan inverse x plus tan inverse y. This is an important property. That is, it is tan inverse x plus y upon 1 minus x plus xy, which is also mentioned for tan a and tan b in normal or original trigonometry without understand not for inverse trigonometry only. Okay, So these are your important properties that you can actually revise through or go through. If you have already studied them, you can leave them. Okay. So y is equals to fx is equals to sine inverse 2x upon एक्स स्क्वायर ओके सो यहाँ पे आप क्या लोगे एक्स के में कुछ सब्स्टिट्यूशंस करो ठीक है these are the substitute because you, at this point of view there is no point of teaching you the substitutions you have to just understand these properties okay you just understand them that is sine inverse 2x upon 1 plus x square is minus pi plus 2 tan inverse x when the domain when the domain that is x is lesser than minus 1 and it is equals to 2 tan inverse x when x when the domain as is defined between minus 1 to 1 pi minus 2 tan inverse x when the domain is defined for x greater than 1 and fx is equals to tan inverse 2x upon 1 minus x square when it is defined for minus 1 to 1 exactly okay so you can actually see here okay and you have to remember these cases for some points okay now we are talking about compound angles. So these compound angles are the basic. These they carry the basic properties as well as the basic derivations for trigonometric functions. Okay, so these are some properties. Okay, you can actually go through them. That is sine square theta plus cos square theta is equals to 1. I think everybody remembers that. This is 1 plus tan square theta is equals to sec square theta. Okay, 1 plus cot square theta is equals to cosec square theta and cosec square theta minus cot 2 theta, cot square theta actually, this is not cot 2 theta, this is cot square theta is equals to 1. And also you can resolve these properties for every case, okay? In circular system, we know that we are defining the angles as well as in your degrees and as well as in your radians, okay? So degree to radian conversion, I think everybody knows this. Yes, I think everybody knows this. That is if we have 90 degrees, so 90 degrees will be what? It will be divided by 180 divided by 90 degrees and we know that 180 degrees is actually sorry 90 degrees will be what will be pi by 2 okay we know that the value of what 180 degrees is equals to pi similarly 270 degrees and 360 degrees can also be understood in the very same case 270 degree divided by 180 degree so this is 3 pi by 2 this is 360 degree divided by 180 degrees. So this is what this is equals to 2 pi. Yes. So I think everybody of you can understand this. So these are the reduction formula. See, reduction formulae are very important for the sake of IMUCET. Okay? Because many a times they ask you the questions from these properties directly. Okay. That is sine 90 plus theta is equals to cos theta. Cos 90 plus theta is equals to minus sine theta. Tan 90 plus theta is equals to minus cot theta. So for this, I can help you to understand this with a single rule. That is, if you have these quadrants, okay, yes. So this is the first, second, third, fourth. Okay. So this is all sine, tan, and cos theta. Okay, so you can actually see that sine 90 plus theta, that is sine 90 plus theta will be lying somewhere here. That is the value of sine 90 plus theta will be lying somewhere around here. Okay, so this is lying in the second quadrant, and we know that for the second quadrant, every value of sine is positive. That is sine 90 plus theta will be cos theta, which is positive in this case. You can actually see that the same for cos 90 plus theta. Cos 90 plus theta, we know that cos is only positive in the fourth quadrant. So you can actually see that cos 90 plus theta is actually equals to minus sine theta and tan 90 plus theta, and you know that tan 90 plus theta or or whatever the value of tan is there, it is only positive in the third quadrant, but now we are only talking about the second quadrant, so it will be minus, that is tan 90 plus theta will be equals to minus of cot theta. Okay, yes, so basics of trigonometry have been clear, reduction formulas have been taught to you. Okay, so this is how you can actually resolve for every other case that is present here. Okay, the graphs for six trigonometric functions, I think that you guys at least are familiar with the graph of sin x, which looks something like this. Okay, and for the graph of y is equals to cos x, the graph is something like this. Okay, we will now have the graphs for tan x, cot x, and cosec x exactly. Okay, so you can actually see or you can get a good glimpse of these graphs. Okay, and these properties are very important for you. Okay, just hope that I hope that you guys are actually into understanding properties than learning them. Okay, so sine a plus b can be understood using sine a cos b plus cos a sine b. Sine a minus b can be written as sine a cos b minus cos a sine b, and you can actually resolve every values of sine as something like this. Just say that I have the value of I have to find the value of sine 2 pi by 3. Okay. Just I have to resolve the value of sine 2 pi by 3. Okay. So how can I do this? I can do this with the help of something like this, that is pi plus pi by 3, pi plus pi by 2. No, sorry, just wait a minute. Yeah, just take an easy example to be very honest. Let us take an easy example. That is, if I want to take sine A plus B is equals to sine A cos B plus cos A sine B. Okay. Now I have to find the value of sine 90 degrees. Though everybody understands that the value of sine 90 is always 1, but it can be written as this also, no? That is sine 60 plus 30. So this can be sine A cos B plus cos A sine B. Yes, I think you guys can understand this using this way. That is sine A plus B is equals to sine A cos B plus cos A sine B. Yes. So similarly, you can also resolve tan A plus B into tan A plus tan B upon 1 minus tan A tan B, tan A minus B, tan A minus B upon 1 plus tan A tan B, cot A plus B, cot A B minus 1 upon cot B cot A, cot A minus B, cot A cot B plus 1 upon cot B minus cot A. So you can actually resolve every values for this using these functions or the trigonometric functions for these compound angles. Okay. So this is also is important. You should also go through this because ये जो properties हैं they can be asked as a MCQ. Okay, sine A, sine 60 minus A, sine 60 plus A is equals to 1 by 4 sine 3A, cos A, cos 60 minus A, cos 60 plus A is equals to 1 by 4 cos 3A, tan A, tan 60 degree minus A, tan 60 plus A is equals to tan 3A. Okay. Yeah, so these are were about the compound angle properties. Now we have the transformation formulae. Okay, transformation formulae is also used in the very same way. That is, now we have to transform the product into sum or difference. Okay, so here you can actually see that 2 sine A cos B, that is, it is the product. 2 sine A is multiplied with cos B, and you are now resolving it into the sum or difference. So it is actually sine A plus B, sine A minus B, 2 cos A sine B, sine A plus B minus sine A minus B, 2 cos A cos B, cos A plus B plus cos A minus B, 2 sin A sin B, cos A minus B minus cos A plus B. Okay, so this is how you can actually understand the transformation formula. Sin C plus D, sin C minus D, cos C plus cos D, cos C minus cos D. So they can be resolved as 2 sin C plus D can be written as 2 sin C plus D by 2, cos C minus D by 2, sin C minus sin D can be resolved as 2 cos C plus D by 2 sin C minus D by 2, and cos C plus cos D can be resolved as 2 cos C plus D by 2 cos C minus D by 2, and cos C minus cos D can be defined as this. Okay, so this is how you can actually resolve them. Okay, the values of trigonometric ratios of standard angles sine 15 degrees. So don't worry that if you are not able to calculate sine 15 degrees in that way, you can use a calculator, because for your examination sake, you are always provided with a calculator in IMUCET exam. If they are asking you about the exact value, then you have to use these calculators. Okay, but when they are asking you regarding this, so I think everybody can express sine 15 degrees as sine 45 degrees minus sine 30 degrees. Yes or no? You can do this. Yes. And if I'm doing this, sine A minus B, which looks something like this, then sine A minus B will be what? Sine A minus B will be equals to sine A plus B minus 2 cos A sine B. Okay. You can actually resolve this property from here, and you can actually solve this. Okay. Sine 2a, this is an important property. Sine 2a is equals to 2 sine a cos a. Just say that I have to find the values of sine 60 degrees. Sine 60 degree can be written as sine 2a. Yes or no? Sine 2 into 30 degrees. Okay. So this is what? This is actually equal to 2 sine a cos A, and this is how actually you can find out the values of sine 2a. Okay, cos 2a is what? Cos square A minus sine square A, and upon writing sine square A as 1 minus cos square A, you can actually get this property also, that is 2 cos square A minus 1. Okay, yes or no? And you can also divide these properties by tan. ठीक है, इसको आप tan से डिवाइड कर लोगे तो यू विल बी गेटिंग दिस 1 माइनस tan स्क्वायर ए अपॉन 1 प्लस tan स्क्वायर ए। tan 2a इज इक्वल्स टू 2 tan a अपॉन 1 माइनस tan स्क्वायर ए। sin 3a 3 sin a minus 4 sin cube a cos 3a 4 cos cube a minus 3 cos a and tan 3a. So this is how exactly you can resort for the double angle and triple angle properties for the trigonometric functions. Okay, so this is the sine series. Okay, sine series. What you have to remember is that you have to remember this general result for this, that is sine n beta by 2 sine beta by 2 into sine a plus n minus 1 beta by 2. I think if you have studied arithmetic progressions, this is the formula for the nth term of an AP. In this case, the common difference d is equals to beta by 2. Okay, the common difference d is equals to beta by 2, and alpha will be what? Alpha will be the first term. Okay, yes, I think you can resolve this now. The value of standard angle, so I think that we have studied this already, matlab ki we can actually resolve this. Just say that you have to find the values of sine 15 degrees. So sine 15 degrees can be found out using sine 45 minus 30 degrees. Okay. For this, just imagine that sine 18 degrees, what sine 18 degrees is something that you have to actually remember, because sine 18 degrees cannot be resolved very easily. Okay, so it is better for us to actually remember these values rather than understanding this. Okay, because sine 18 degrees is somewhat tedious to derive using those examples. Okay, so we will take the calculative approach, that is, we will try to memorize it now. Okay, and sine 22.5 degrees can be resolved using sine 2a is equals to sine 2 into 20, 25 22.5, that is sine 45 degrees. Out of that, you can calculate the value of sine A and sine B. Okay. Yes. So this is how you can actually understand this. Now, sine 2A, sine 2B, sine 2C, and these are the properties which are regarding the application for trigonometry in maximizing and as well as minimizing problems, which we'll study later in the application of derivatives chapter. Okay, so this was about the entire trigonometry. Now we'll study about sequences and series. I think everybody of you knows about sequences and as well as a series. So the first topic will be AP and GP. So AP will be 1, 3, 5, 7, 9. So the first term will be what? The first term will be A is equals to 1. The common difference, that is the successive terms of this AP, are increasing by 2. And yes or no, you can actually understand this. So you can see that for this, the first term will be A and the second term will be 3. Yes, because the first term was starting with 1, and the common difference now, the second term has been increased by 2. So you have got 3 now. Okay. So in this way, you can actually define the values for Tn, that is for the nth value of a given term, can be as a plus n minus 1 into d, which is actually mentioned here. Okay, and the summation, that is n by 2 2a plus n minus 1 into d, that is n will be the number of terms, 2a will be the first term, n will be the number of terms for of which you have to calculate the sum of, about d will be what? D will be the common difference of these two terms actually. Okay, the sum of the first n natural numbers. So I think that you guys actually understand this, that is, this is b equals to n plus 1 by 2, n into n plus 1 by 2. This should be n into n plus 1 by 2. The sum of the first n odd numbers will be n square. The first sum of the first n terms will even numbers will be n into n plus 1. Okay, the sum of the n terms of an AP is of the sum is of the form Sn is equals to Pn square plus Qn, that is a quadratic expression in n. The nth term in the series Sn is equals to Sn minus Sn minus 1. Okay, so because if we have the sum as Tn, so we can actually, we actually have the sum as Sn. So if I want to find about the given term, so उस टर्म को निकालने के लिए हम कैसे कर सकते हैं? मान लो कि हमें एक फिफ्थ टर्म निकालनी है, तो हम क्या कर सकते हैं? सिक्स टर्म का सम निकाल लें और फिफ्थ टर्म तक का सम निकाल लें, फोर्थ टर्म तक का सम निकाल लें. ठीक है, S6 minus S4 करेंगे, so we will be actually be presented with the fifth term only, no? Yes or no? Because the six term तक का सम तो सिक्स टर्म तक की सम था, फोर्थ टर्म और सिक्स टर्म के जो सम का डिफरेंस होगा, that will be the fifth term. So now we will differentiate between the difference, we take the difference between S6 and S4, and we'll be getting the fifth term in this case. Yes, so I think this was clear to you. Okay, if A, B, and C are in AP, then if A, B, and C are in AP, obviously if three numbers are in AP, then A, comma B, comma C. So this will be B minus A will be equals to C minus A, because given that they are in AP, so their common difference will be same. So B minus A will be equals to C minus A. I think this is clear to you guys. Okay, in property 3, in an AP, the summation of the kth term from the beginning and the kth term from the last is always constant, which is equals to the summation of the first term and the last term. That is kth term from the beginning, that is tk, n plus k n minus k plus 1, that is nth term from the beginning minus the kth term from the end plus 1. Okay, so this is how you will actually understand the third property now. The property 4, any term of an AP except the first and the last is equals to the sum of the terms which are equidistant from it. That is TR is equals to TR minus K and R plus K divided by 2, where K is less than R. Yes, is that clear, every one of you? So now we will see toward the supposition of the terms of an AP. Okay, so just say that I am talking about three terms in an AP. Just say that 3, 5, and 7. Okay, and now if I want to take the terms in the supposition, that is, I have to take the suppose of things. That is, if I want to suppose this, so this f can be the second term, that is, I can write it as a. Yes, this will be a, and this will be a minus d, and this will be a plus d. Yes or no? Because the first term is actually a and the second term is actually a plus d. So now what I have supposed is that the fifth term, that is the second term, is now a, that is 5. Okay, and the 3 will be what? A minus d, and 7 will be a plus d in this case. Okay, the arithmetic mean, just say that for three numbers you have, okay, three numbers will be what? For two numbers actually, a comma b, the arithmetic am will be a plus b divided by 2. GM, that is the number of geometric mean will be what? Under root of AB. Okay, and if you have to insert n arithmetic numbers between two numbers, that is, you have this formula, that is d is equals to b minus a upon n plus 1, where d is the common difference of the difference between these arithmetic means. That is, these arithmetic means will be equidistant to each other. They will also be in any AP, and the AP will be found with the common ratio d is equals to b minus a upon n plus 1. The summation of n number arithmetic terms between two numbers is actually the very same. If you have found out the AP, okay, if you know the first term and you have d, you can actually find out the sum, which is given as something like this. Okay, now we have GP. If we have 3, 9, and 27, you can actually see that these three numbers are what? They are separated by the multiple of 3. That is, this is 3, this is 3 into 3, and this is 3 into 3 into 3. Yes, so you can actually see that these three numbers are actually separated by 3 comma 3 into 3 into 3 into 3 into 3. Yes or no? So you can actually see that they are the geometric progressions in this case actually. Yes, now the geometric progression is represented in this term, a to the power rn minus 1. Yes, so in this case, a is what? This is the first term. R is what? This is the common ratio. Yes, the ratio which the numbers are multiplied, the successive numbers are multiplied, which is 3 in this case. Yes, and n is the n is the index of the number. That is, for this number 3, the index is 1. This is 2. This is 3. So n is the index of this number. Okay. So for three terms in a GP, let us say that T1, T2, and T3 are in GP. So this will be T2 upon T1 will be equals to T3 upon T2. Yes, so this will be followed for the common ratio of GP. Mth term from the end of n GP will be equals to the n minus m plus 1th term from the beginning. Okay, that is Tm will be equals to Tn minus m plus 1 from the beginning. Yes, is that clear? The summation of n terms of n GP, ठीक है, S infinity will be equals to a upon 1 minus r. This is the most common asked question, that is, if you have a term 1, 1 by 3, 1 by 9, and it is extended until infinity. So a will be what? A will be 1 upon 1 minus 3. So your answer will be what? I think your answer will be 3 by 2, which is for this case actually. And the summation for n terms, that is, this will be equals to a into 1 minus r to the power n upon 1 minus r, which is equals to the sum of the n terms of a given GP. Yes, I think this is clear to every one of you now. For the properties of a GP, this is equals to b by a is equals to c by e. That is, b square is equals to 2ac. In that case, it was b is equals to a plus c by 2. Now it is b square is equals to ac. Yes, if three numbers are in AP and if we are now multiplying it by the very same constant number, then those numbers will all the new form numbers will also be in GP. That is Ka, Kb, Kc will also be in GP. Yes. In GP, the product of the kth term from the beginning from the last is always constant, which is equal to the product of the first as well as the last term. In a positive GP, every term, the first step, the first and the last term is equal to the square root of the product of its two terms, which are equidistant from it. Okay. So these are some properties that you can actually take a glance upon. Okay. The supposition, as exactly we had studied about AP, we will study the same about GP. That is, if we are supposing the second term now, that is for 3, 9 and 27. If I'm supposing the second term, okay, so the first term will be 9 divided by 3, while the third term will be 9 into 3. So this is what? This is a by d, a by r, this is r, and this is r into, and in whatever you can call it, okay, er. Yes, exactly. I think this is a by r, a into ar. Okay, is that clear, every one of you? Yes, so the geometric mean we have studied it before. Okay, the n geometric means will be a under root ab to the power n, that is equals to gn in this case. Okay, so this is an important thing that you have to understand. That is n gms, that is the total number of geometric means that can be in between two numbers. That is, if I have a number 3 and 81, so the number of geometric means between them will be under root of 3 into 81. This will be under root of 243 to the power n. So you can actually resolve this. Okay, and this n will be the total number of geometric means which will be lying in between them. Okay, harmonic progressions. Harmonic progressions is 1 upon a plus 1 by b, 1 by c. Okay, so harmonic progressions are not very important. In this case, a b c, a1, a2 and a3. Let us talk about a b c, because it is a1 upon a, 1 by b, 1 by c. So first understand that for a b c, when A, B, C are in AP, when these three terms A, B, C are in AP, then you can only say that 1 by A, comma 1 by B, comma 1 by C, they will be in an HP. Okay, for 1 by A, 1 by B, and 1 by C to be in HP, you have to make sure that A, B, C are in what? They are always in an HP. Okay, is that clear, everyone of you? The general form of an AP, if A is the first non-zero term and B is the non-zero common difference of an AP, then the standard AP HP will be what? It is 1 upon A plus 1 upon. So what you have to do is that in terms of HP, you have to just take every case of AP and you have to take it as an inverse. That is, if it was one, the first term was A there, so this will be 1 upon A. If the second term was A plus D, so here it will be 1 upon A plus D. If it was 1 plus 2d, a plus 2d, this will be a upon a plus 2d now. Okay, so this is how actually you can understand this. Yes, is that clear? So now the relation between AM, GM and HM, that is G square is equals to AH, that is the geometry, the square of the geometric mean is equals to the product of the arithmetic mean as well as the harmonic mean. And you should always remember this relation, that is AM is always greater than GM is always greater than HM. This is sometimes directly asked in an examination and you have to take the utmost care of this. Okay, and the harmonic mean for two numbers is what? H is equals to 2ab upon a plus b. Okay, when three quantities are in HP, then the middle one is called as the harmonic mean of the other two. If A, B, C are in HP, then B is equals to 2AC upon A plus C. Okay, so this was about sequences and series. Okay, so these are the sigma notations. Sigma notations are also a very important part. So first of all, let us understand about the sum of n natural numbers. That is, it is equals to n into n plus 1, where n is the number of natural numbers that you have been asked. Okay, the sum of the squares of that is n into n plus 1, 2n plus 1 divided by 6, n into n plus 1 divided by 2 whole square. Okay, will be the sum of the cubes, the sum of the first n natural odd numbers, that is equals to 2r sigma summation of 2r minus 1 equals to n square. The sum of first n natural numbers 2r is equals to n into n plus 1. Yes, so this is an arithmetico geometric progression. You can understand this using this way, that is the general form of an AGP is AB dot B A plus D BR, where you have to use both, that is the common difference as well as the common ratio, and the nth term is given by A plus n minus 1 into B BR to the power n minus 1. Okay. Okay, so now we'll start with the chapter quadratic equations. So also quadratic equations is an important chapter for the sake of IMUCET. Okay, many formula based questions and many easy questions are asked from this chapter. So let us start with the first heading of the day, that is about the roots of a given quadratic equations. I think you guys are familiar with the number of roots an equation has. Okay, so if we have an equation ax square plus bx plus c, which is indeed a quadratic equation, the degree of a quadratic equation is what? It is equals to 2. That is degree is equals to 2. Yeah. So when the degree is equals to 2, the maximum number of roots this equation can have is equals to 2. And also the sum of the roots, that is the sum of the roots, can be expressed as the coefficient that is given by minus b by a. Okay. And also alpha beta, that is the product of the roots, can be given by c by a. Yes, so which is also mentioned here for the cubic expressions alpha plus beta plus gamma, because it is a cubic expression since the degree is 3. So the number of roots will be also 3. So alpha plus beta plus gamma will be equals to minus b by a. Alpha beta plus beta gamma plus gamma a will be equals to c by a. And alpha beta gamma will be equals to minus d by a. Okay, is that clear, every one of you? Okay, so obviously if we have a function, we'll have some values, and obviously when we are talking about a given function, we are more concerned with the maximum as well as the minimum values. So the maximum values can be found out at y max is equals to minus d by 4a, where d is the discriminant of the quadratic equation, which is given by under root of b square of minus ac. Okay, yes, and the minimum value can also be given at minus d by 4a, and it occurs at x is equals to minus b by 2a. Okay. Yes, so this is what you have to take care of, and this is what you have to understand. Okay, so biquadratic equations do also have the very same formulas. You can check that out. Yes, and now we are having the resolving a general quadratic expansion in x and y into two linear factors. I think you guys are familiar with Sridharacharya's method. Yes, Sridharacharya's method हमने पढ़ा था कि how we split up the middle term. So that was for basic quadratic equation, right? And now the range of functions expressed in the form of px upon qx, where p and qy are either linear or quadratic polynomials. So this is for linear by linear types. This is for the linear and quadratic type, and quadratic by quadratic type. And this is also a format for quadratic and quadratic type. Yes, symmetric expressions. Okay, so what we have, the symmetry expressions of the roots alpha beta of the Fn equations are those expressions in alpha and beta which do not change by interchanging alpha and beta. That is, if you change beta with alpha or alpha plus beta, they won't change. So you can have some examples of this. That is because it is square. So अगर आप alpha square alpha की जगह beta कर दोगे, still you will have the same. यहाँ पे भी you have the same. Here also, here also. See, so these are the symmetric expressions for the quadratic equations. Okay, the condition for common roots, this is an important question for the sake of IMUCET. Yes, so if you have the common root alpha, let us say that both of the equations have a common root alpha. So this root can be calculated using b1 c2 minus b2 c1 a2 c1 and minus a1 c2, where a1 b1 and c1 are the coefficients of the first equation, while a2 b2 and c2 are the coefficients of x and x square in the second equation. Okay, and this is the first condition for a common root. The conditions for both the common roots, that is, this is only valid when we have a single common root. Okay, but now we want that both of the roots should be common to both of the equations. So we now have a1 upon a2 is equals to b1 by b2 is equals to c1 by c2. This is how we use the formula to calculate the condition for common roots, that is both of the roots should be now common. The formulation of quadratic expressions whose roots are symmetric of expression alpha and beta. Okay, ax square plus bx plus c, then the equation whose roots are minus alpha comma minus beta, replace x by minus x. Yes, so now what we are doing is that we are just changing the expression to the symmetric expression. That is, हम एक symmetric equation, this is not at all very important for the sake of IMUCET, though you can skip it. Yes, so now the quadratic expression and its graph, that is, if a is greater than 0 and d is greater than 0. Yes, so this graph is important. You can check this out. The second graph, that is when a is greater than 0 and d is equals to 0. Case 3, if a is greater than 0 and d is lesser than 0. And case 4, if a is lesser than 0 and d is greater than 0. Yes. Case 5, if a is lesser than 0 and d is equals to 0. Case 6, if a is lesser than 0 and d is lesser than 0. So these are the important cases that you actually have. The location of roots. Location of roots is something that is important. Okay, we have some 5 or 6 cases here. To be precise, we have 5 cases actually, and these 5 cases are something that you should take care of really. Okay, so both of the roots of the quadratic equation are greater than the specified number d. So that, let us say that we have taken a number d, that is we have a fixed number d on this number line. Okay, and I want to make sure that the roots that I'm getting for this quadratic equation, they are all greater than this number d. So for that I have to make sure a dot fd is greater than 0. That is a, that is the coefficient of x square, yes, multiplied by fd, that is the number chosen. D will be, should be greater than 0, and minus b by 2a should be greater than the number. Yes, so this was the first condition. For the second condition, that is I have number d, and I have to make sure that both of these number alpha and beta, they lie on the either side of this number d. Okay, so both roots lie on the either side of fixed number d. So alternatively, one root is greater than d and the other is less than d, and it lies between roots of the given expression. Okay, type 3, when both the roots are confined between the numbers d and e, that is d is lesser than e. Condition for this are d greater than 0, a dot fd greater than 0, a dot fe greater than 0, and d minus b by 2a is lesser than or equal to d. Yes, so this is the third type. The type 4, one root is greater than e and the other root is lesser than d. This is what is also important. Okay, so guys, make sure that you catch a glimpse of these topics. Okay, proper explanation cannot be done for the sake of mind maps. Okay, so type 5, exactly one root lies in the interval d e, and when d is lesser than e, condition for this are f dot e dot f dot d fd dot fe is lesser than 0. Okay, and another case arises when fdfe is equals to 0. Then for fd is equals to 0, this should be the case. Okay, and for fe, this case is not actually very, so this looks something like this. That is, this is actually alpha, this is beta, and this is, okay, this is for the second case. Sorry, e is in between. Okay, polynomial is a function that is a degree of where all the powers of x are non-negative integers, and a, which should be leading coefficient of the polynomial, should not be equal to 0. That is, n is equals to ax plus 1 a1 linear polynomial, and is equals to 2 a dot x square plus a1x plus a2 quadratic polynomial, n is equals to 3 a dot x cube plus a1x square plus a2x plus a3 is a cubic polynomial. So this is how you can find out difference. So I think remainder theorem is something that is you have studied a lot time before. That is the long division method. Factor theorem, that is how you are factorizing things. The nature of the roots, are defined by the discriminant. That is, if the discriminant is greater than 0, then the roots are real and distinct. If it is equals to 0, then the roots are equal, and if it is lesser than 0, then the roots are imaginary. Yes, the solution also minus b plus minus root d upon 2a, where minus b is the coefficient of x, b is the discriminant, and a is the coefficient of x square. The relation between roots and coefficient, ax square plus bx plus c, where a is not equals to 0. If alpha and beta are the roots of, then alpha plus beta is equals to minus b by a, alpha beta is equals to c by a, alpha minus beta is equals to root d by a. The formation of a quadratic equation when roots are given. Yes, so you know that if a quadratic equation has x square plus 3x plus 2, so obviously this equation has some roots. Yes, so this can be formulated using x minus alpha into x minus beta, where alpha and beta are exactly the roots of this given quadratic equation. Yes, so now we'll move towards logarithms. Logarithms are not important for as an individual chapter, but they are used in almost every chapter of mathematics. Okay, and many a times they can ask you these basic properties of logarithmic. Okay, okay, so the first thing is that log base n 2n, that is when these numbers in both as well as the number are same, you get 1. Okay, log base 1 upon n into n is equals to minus 1. Log base e1 is equals to 0. That is, you have to make sure that the base and as well as the number basic constraints, okay, they should be same. Okay, only when you can say that this is equals to 1, that is log n to base n is 1. Yes, that is log base am plus log m plus log n when the base is same is equals to log mn. So these are the things that you can take good care of while seeing this. That is basic base changing theorem. Log base c a log base c b is equals to log b log b by a. That is, you have already studied that log a minus log b is equals to log a by b. Okay. ठीक है. So this is how you study about the base changing theorem, that is now you have changed the base. Okay, the base has been changed to a constant because it was already same, so now we have kind of eliminated this, and this is only log ba. The important results on b base a, that is log ba is equals to log 1 upon log base a b, log base b a, and log base c b, log base d c is equals to log base d a. So this is what you have to make sure, that for the last base was constant and the first constraint was constant, so log base d a. Okay, this is also important, so you can take a good glance on these topics, that is a graph of logarithmic functions. This is important, the characteristics and mantissa, that is log base a is equals to friction positive, that is the integer part, and the frictional part is the integer part is called as the characteristic, and as well as the fractional part is called as mantissa, that is denoted by n. The mantissa part of the number of is always positive, that is 0 plus that is, we know that the log is not defined for negative integers, so we have to make sure that the mantissa, that is a forming of a of a number, is always positive. If the characteristics of log base 10 will be n, then the number of digits is n is n plus 1, just like this, that is log base 10 100. So the number of digits in this is actually 2, so the number of digits here is denoted by 2 plus 1. Okay, if the characteristics of log base 10, if the characteristics of log base 10 and b equals to minus 1, then there will be n minus 1 zeros after decimal and before first significant digit in n. Now we are studying continuity. So continuity of a function can be defined as ki how easily you can draw it with a single stroke of pen, that is without lifting it. If you can draw a function, then you can say that that given function is a continuous function. Yes. So we will first have to understand about the limits. That is, a function x is said to be continuous at a given point x is equals to a if limit fx exists and is equals to fa, and if limit a minus h exists is equal such that it is equals to limit of fa h tending to 0, a plus h is equals to fa, that is a finite quantity. That is, we have to make sure that if this a is our function, if a is actually the point at which we have to find out the continuity, so this should be the LHS, and this should be the LHL, and this should be the RHL, that is the left hand limit and the right hand limit should be equal. Only when they will be equal you can say that this given function is a continuous function, elsewise you cannot say that given function is a continuous function. Yes. So now the reasons of discontinuity, the function can be continuous due to the following reason, that is limit of fx does not exist, limit of fa plus h limit is not equals to limit of a minus h, that is सबसे पहला condition यही है कि जब continuity नहीं होगी, that is LHL will be not equals to RHL. Yes, the limit exists but it is not equal to fa, that is this value of fa is not equal to LHL or RHL. Okay, so in that case also the case of continuity fails. Yes. So now we are talking about the type of discontinuities. The type 1, that is removable discontinuity. Here removable limit of fx necessarily exists, therefore it is possible to redefine the function in such a manner that limit x tending to fx is equals to fa, thus making the function continuous. That is, we have now made sure that the limit exists. Okay, so now it is possible for us to say that the limit of f tending to x tending to a fx is equals to fa. All polynomials, trigonometric and exponential and logarithmic functions are continuous in their domains. Mind you that this statement is important, that they are only continuous in their domains. For rest of the problems, that is for the points outside their domains, you have to check it separately. If fx and gx are two functions that they are continuous at x is equals to c, then the function is defined by f1x is equals to fx plus gx. Okay. Yes, I think this is clear to you guys. The types of discontinuities. If fx and gx are two functions that are continuous at x is equals to c, then the function is defined by f1x is equals to f1 fx plus minus gx, and f2x is equals to kfx, where k is any real number. F3x is equals to fx dot gx are also continuous at x is equals to c. Further, if gc is not 0, then f4x is equals to fx upon gx is also continuous at x equals to c. That is, you have to first understand that key, if there are two functions, okay, and they have been given that they are continuous at a given point, that is x is equals to c, then these functions can, then a common function that can be found by performing those algebraic expressions on this, that is the expression of addition as well as subtraction, that is f1x, which is found by, let us say that f1x is equals to fx plus gx. Yes, and f2x, that is f2x is the same fx, but now it is multiplied by a constant k. Okay, and f3x is the product of fx and gx. Yes, So now what I can say that this fx and gx, that is fx and gs, will also be continuous at x is equals to c. So mind you that performing any sort of algebraic expressions on any two functions which are actually continuous at a common point does not have any effect on their continuity whatsoever. Yes, the isolated point discontinuity, where limit fx exists and fa exists, but also limit of x tending to a is not fa. That is, for this type of function you have to make sure कि fa तो एग्जिस्ट कर रहा है फंक्शन का, लिमिट ऑफ एक्सटेंडिंग टू ए भी एग्जिस्ट कर रहा है, बट वो दोनों बराबर नहीं है, ठीक है। तो इस केस में क्या होता है, दैट इज द आइसोलेटेड पॉइंट डिसकंटिन्यूटी। टाइप 2 नॉन रिमेंबर्ड discontinuity, where here limit of extending to a fx does not exist, therefore this is not possible to redefine the function in any manner to make it positive. Okay, so this is the case which is presented here. Yes, the finite type, both the limits are finite but are not equal. Yes, this is for the LHL as well as RHL. Continuity and an interval. So the function fx is said to be continuous in a comma b if the function fx is continuous at each and every point at a into b. That is, अगर आपके पास एक कोई given function है and that is resorted into two intervals, that is, let us say this interval is a and this is interval b. Okay, so now this function is resolved into a into b, and we have to say that this given function is continuous in a and b. So we can only say this only and only when they will be continuous everywhere. Let us say that I am imagining this point as a1 and this is your point a2 and this is a3 actually, and I can only say that these points are continuous. Only this function is continuous in this interval only when a1, a2 and a3 are also the points of continuity for this given function in the interval a and b. Yes, the function fx is said to be continuous in the closed interval a dot b if fx is continuous in the open interval a comma b, if fx is right continuous at a and fx is left continuous at b. Okay, so the continuity of a composite function if fx is continuous at x is equals to a. So this is the same thing that we have studied before, but now this is about the continuity of composite functions, that is the functions which are written in some form of f of g and g of f. Okay, so these are the important cases of the composite functions. Okay, similarly if fx is continuous at x is equals to r and gx is continuous at x is equals to r, then the composite function g of fx is also continuous at x is equals to r. Okay, yes. While checking the points of discontinuity of g of f always includes the point of discontinuity of fx. This is something that you have to take care of and you can take care of it as a note. The intermediate value theorem. Intermediate value theorem says that if we have two function, okay, and they are continuous in the interval a comma b. Let us say that this is a function a fx, yes, and now I have bounded these functions into an interval a as well as an interval b. Okay, so this is now a case of closed intervals, that is the function fx is now bounded by two closed intervals. Okay, yes, so then we'll have to read out the statement, that is, then for every value c between f and if there exists one value in which fx is equals to c, that is fx is continuous in a and b, that is f dot a b is lesser than equal to 0 and f and b possess opposite signs. Okay, so there will be an point c. This is the point c that we are talking actually about, that is ये वही point c होगा for which there is at least one number for it, that is f dash c is equals to 0. At this point the value, the derivative of this function will be actually d0. We will study a little more about it when we will study LMVT, that is Lagrange's mean value theorem as well as the Rolle's value theorem. But up till here you can just understand it about here, that is at least one root. That is one root matlab kya? That is this place where the root, that is the derivative will be 0, will be this point, that is which is also mentioned here, that is fx is equals to 0 in a comma b. Yes, the important points fx and gx are continuous function. Okay, this is what we have already studied, so we won't study it again. Yes, yeah, the point functions are treated to be continuous if the domain of x is a singleton and fx is a continuous function. Obviously, if we are talking about a point function, that is, if we are talking about a function which is looking like something like this, so obviously this function will be continuous because it is only defined for a single point. Yes, so there is actually no case for the line left hand limit and RHL. They will all be equal to fa only. Yes, so this case will be that the point functions are treated as continuous. If a function fx is continuous in a closed interval ab, then it is bounded. A continuous function whose domain is some enclosed interval must have its range also in closed interval. Obviously, if the interval, the domains, that is the input is constrained, then the output will also be constrained in between some interval. Yes. Now we have limits. So limits is actually the chapter which is studied in accordance to continuity. Okay. So something of limits is actually related to continuity. So pay attention to it actually. So let a function fx at any point x is equals to a is either not defined or is indeterminate. I hope that you guys know about that defined or indeterminate form of a limit, but it is defined and finite over left hand and right hand neighborhoods points very close equals to x is equals to a. Then the value of the function at the neighborhood is called as the limiting value of this given function. The right hand limit, that is when x is equals to a, that is if we have this given function. Okay, and I'm now talking about this point A actually. So there is something, no, that is we are approaching this point A from the right hand side, yes, and there can also be a chance that when we have approached this function from A, we are moving away from it, right? Yes, this looks something like this. So this will be moving away from A, and this will be moving towards. So this will be your RHL, that is the right hand limit, and this will be the LHL, that is the left hand limit. Yes. Yes or no? Is it clear to every one of you the existence of a limit? If LHL is equals to RHL, then it is a finite quantity. Both limits exist equal and finite. Let limit f extending to a fx and limit f tending fx extending to minus a is the finite quantity. The fundamental theorems of limits, take the constant multiple rule, that is k multiplied by any limit will be a constant sum rule. Fx plus gx will be equals to L plus m. Difference rule, limit of x tending to c, fx minus gx will be equals to L minus m. The product rule will be L dot m. The quotient rule, limit fx upon gx will be equals to L upon m, where and m will be not equals to 0. So this is something that you have to take care of. You have to take care of it at real means. Okay. So now limit log fx is equals to log limit fx is equals to log L. Yes. अगर log लिमिट का ले रहे हैं तो log, जैसे कि we can perform, that is the fundamental theorem of limits say that you can perform any sort of algebraic expression that you can perform on two numbers exactly the very same way on the two limits, that is fx and gx. बस कहने का मतलब यही, ठीक है. Yeah. So the fundamental of limits, that is limit of mod fx is equals to limit of mod fx extending to a is equals to mod of L. Yeah, so this is very same as the numbers that you are studying right now. So the indeterminate forms can be 0 by 0, infinity by infinity, and infinity minus infinity, and 0 into infinity. So the most important two forms are obviously 0 by 0 and infinity by infinity, as well as sometimes is infinity, m minus infinity. Okay. The factorization methods, okay, that is limit of fx and gx when x is tending to a by substituting a, x is equals to a, fx and gx reduced to the form 0 by 0, then x is a factor of both fx and gx. Yes or no? Obviously we know that if we have numbers, that is अगर x square minus 3 है और x square okay, just wait a minute. Yeah, x square minus 3 है ये. So this can be resorted into x plus root 3 and x plus minus root 3. Yes or no? So like just take it as a case. Don't take it as a very straight example, but take it as a case only. That is, it will be x plus root 3 and x minus root 3. So what you can actually see is that in both of these cases, this x plus root 3 and x plus minus root 3 are what? They are the common factors of both fx and gx. So we first factorize fx and gx and then cancel out the common factor. Okay, so upon cancelling them out, we can actually see that the limit for this given function will be 1 only. Yes. So we don't have to put out the limit a because this function is actually getting cancelled using the that cases of what we are just taking the common roots, so they are actually cancelling, getting cancelled out. So this is the general result, that is limit of x tending to a, x to the power n minus a to the power n upon x minus a will be equals to n a to the power n minus 1. So this is what you have to study. Actually, this standard method is important. Sometimes questions are asked straight away from here. Okay, so if you want, I can actually help explain this with an help of an example. That is, if it is equals to x square minus 2 square and x minus 2. So the value of n in this question is what? N is equals to 2. Yes, a is also equals to 2. Yes, so if I want to write this, I can write this as 2a to the power n minus 1. So 2 into 2 is equals to 4. Yes, so I think this was clear to every one of you. Yes, the rationalization method. This is the method particularly used when either the numerator or a denominator of both involved expressions consists of square roots, and on substituting the value of x, the rational expression takes the form 0 by 0. Okay, so these are some things that you can use, that is using the standard limits function, the sandwich theorem or the squeeze place theorem, that is fx, gx and hx be three functions such that fx, gx and hx, obviously if you have three functions, you will have some difference in between their values. Yes, the one of them will be least, the second will be little greater, while the third will be the greatest. So this is how we have sorted out these things. Yes. So for all values of x in some neighborhood of x is equals to c, limit x tending to c, fx is equals to limit x tending to c gx, and limit hx x tending to c. The limits of trigonometric function limit x tending to 0 sin x upon x is equals to 1, limit of x tending to 0 x minus a upon x minus a is equals to 1, limit x tending to 0 tan x minus a upon x minus a is also equals to 1, limit of sine inverse x upon x is 1, and this is also the following result for these functions. So we have to take a good care of them. Okay, this is for the result of the greatest integer functions, and you can also take a good glance of them. Yes. So now this is an example related to the exponential and the logarithmic functions, that is limit of ex to the power ex minus 1 to the power x is equals to 1, limit of ax minus 1 upon x is equals to log and ln a. Ln a, mind you that this is not log a, this is ln a. Ln 1 plus x upon x is equals to 1, 0 to the power 0 and infinity by 0 forms, they can be solved using this ways. ओके आप एक लिमिट लो, ठीक है, जस्ट टेक द log of it and then solve them separately. So now they will be sorted out as two functions, that is fx and gx. Okay, and you have to sort them out by finding out the limits and then multiplying them by each other. That is 1 by 0 form, limit of 1 plus x to the power 1 by x is equals to e, limit of 1 plus 1 by x to the power x is equals to e. Yes. Now L'Hopital rule, this is the most important rule that you have to study. You have two functions and then you'll have to then differentiate them, and you'll have to differentiate them until and unless these forms appear on the numerator as well as the denominator, that is until you get 0 by 0 or until you get the infinity by infinity form, you have to do the differentiation. And once you get that forms, you have to stop, and whatever the value that you are getting, just substitute the value of the function, substitute the value of the point of which you have to find the limit of, and you'll be getting your answer then. The limits using series expansion. Okay, so we have some common series, that is e to the power x and e to the power minus x. Yes, yeah, we will take a model test paper in some days on the marathon, and then we will sort this out with how we will study this. Yes, is that clear? Now differentiability, the concept of derivative. Obviously, twofold meaning of derivative: physical meaning, instantaneous rate of change of function; geometrical meaning, the slope of tangent drawn to the curve at any point if it exists. Obviously, we are talking about a derivative. So, what do we mean by a derivative? That if it is, we have a very big function fx, right? So fx has a very big range. Let us say that we are talking about x square, right? So fx is equals to x square is something like this, right? And now if I want to do the analysis of this given function, of its ratio, of its rate of increase, and how it is actually formed, the slope, etc. So do I have to sketch this entire function every time? What I can do is that I can take a very small part of this function. Let us say that I'll take this part of this given function. Yes. So this yellow part will be what? This will be the derivative, that this function is actually derived from this part. So it is the derivative of this given function f. Yes, so this is called as a derivative of this given function at x is equals to, let us say this point as a, so the derivative of the function at x is equals to a. Yes. So the left hand derivative fx is equals to m fa plus h minus fa upon h, and the right hand derivative will be fa plus h minus fa upon h will be the right hand derivative, and the left hand derivative will be fa minus h upon minus fa upon minus h. So that only difference I think that you can actually see is between the h as well as the minus h, and this is denoted by fa dash f dash a, which is I think has been studied before by every one of you. Yes. So now all the polynomial, rational, trigonometric, logarithmic, and exponential functions are continuous as well as differentiable in their domains. If the function is yx is equals to fx is differentiable at a, then the unique non-vertical tangent can be drawn at the curve y is equals to fx at point p a f a, and f dash a represent the slope of the tangent at point p. And mod x, that is the greatest integer of x, is a non-differentiable at integers. The signum of x is also non-differentiable at x is equals to 0, as well as the fractional part is also not differentiable at integers. Yes, so this is what you have to take care of. नाउ यू हैव टू मेक श्योर, अगर आपने एक फंक्शन के डेरिवेटिव चेक किया है कि अगर वो फंक्शन वहां पे डेरिवेबिलिटी है कि नहीं, तो अगर वहां पे फंक्शन डिफरेंशिएबल है, तो ऑब्वियसली एट दैट पॉइंट द फंक्शन इज कंटिन्यूअस. Yes, and if it is differentiable, the first thing that you have to take care of is that if the function is differentiable, then it is both differentiable as well as continuous. But you cannot say the thing otherwise, that is if a function is continuous, then you have to check it whether it is differentiable or not. You cannot just say it arbitrarily that this given function is differentiable also. Yes. So now we'll move forward. If f dash a plus is equals to p and f dash a minus is equals to q, when p or q are both may not be finite in this case, f is not differentiable at x is equals to a, and nothing can be concluded about the continuity of function at x equals to a. If f is equals to fx is continuous at x is equals to a and limit of f dash x approaches 0, then y is equals to fx has a vertical tangent at x is equals to a. If a function has vertical tangent at x is equals to a, then it is non-differentiable at x is equals to a. So this is something that you have to take care of. Okay, this is something you can take care of and you can understand this. Yes, derivability over an interval. If fx is said to be differentiable over an open interval a comma b, if it is differentiable at the very point, yes, which is also we have studied about the continuity in a given bounded interval. Yes, if fx is said to be differentiable over the closed interval a comma b, if fx is differentiable in a comma b and for the points a and b, if f dash a plus and f dash b minus exist. The algebra of differentiability just the same as continuity what we have studied. We can perform the different in numerous algebraic expressions on these type of functions and we'll be getting the very same results as well as we were getting for continuity. Not the exact same results, but you can perform the very same things on them. Yes, let fx be a function whose derivative of f dash x, then f limit of y tending to y tending to x, fx minus fy upon x minus y is equals to f dash x. The derivative of a continuous function needs not to be a continuous function. Okay, so if we have taken out a continuous function and then we have taken its derivative, then it is not necessary that the derivative will also be a continuous function. Yes, the methods of derivation. Yes, so I think methods of derivation is something that I think everybody of you knows. I think everybody of you knows how to differentiate values. Yes, I bet you guys can do this. To the derivability by the first principle, that is the first derivative. That is, say that I have a function x square and I want to calculate the first derivative which is given by f dash x. So this will be 2x. Yes, f dash x will be equals to 2x. Yes, and f double dash x, that is now I'm differentiating this function once again. So I'll get 2. That is f double dash is equals to 2. Yes, the sum or difference rules, that is if we are having a function 5x square and now I want to differentiate it, what I'll do is that I'll take the 5 outside and then I'll take the derivative of x square. So I'll get my answer as 5 into 2x, that is 10x will be your answer. Okay, so this was about the first derivative and the second derivative as well as when the function is given multiplied by the constant. Obviously, if you have two functions fx and gx, you can take the derivative of them separately and then add them. The quotient rule, that is if a function is divided by any other function, so what you'll do, first of all, you'll take the first function, multiply it with the derivative of the denominator, then you'll take the second function, multiply it by the derivative of the numerator upon divided by the square of the numerator denominator. Yes, is that clear? So this is how you take the derivative of inverse trigonometric function. Sine inverse x is equals to 1 upon under root 1 minus x square. Cos inverse x is equals to under 1 upon under root 1 minus cos x square, and tan inverse x is equals to 1 upon 1 plus x square. Yes, so this is how you can take the derivative of most of these functions. I think most of these things are actually clear to you guys. They don't need much of a resolution to you. Okay, तो लॉगरिथमिक डिफरेंशिएशन, लॉगरिथमिक डिफरेंशिएशन क्या होता है कि अगर e टू द fx है to the power gx है and I have to take its derivative. Okay, and if it is looking something like hx, okay, so what I'll do is that I'll take the log hx gx fx. Okay, and what I'll do is that now I'll take the differentiation of this. Log hx will be equals to 1 upon hx. Gx will be taken as constant. Fx will be differentiated with respect to x. Then fx will be taken constant and gx will be represented and differentiated with respect to it. Okay, and we'll be getting our very final answer now. The derivative of fx with respect to gx. Let us say that you have function x is equals to t square and y is equals to 2t. Yes, and now I want to ask you about dy by dx. So how you will do this? So to solve this, I'll move this thing here. That is, now I want to solve this. So what I'll do is that I will divide 2t derivative. Sorry, just let me make things a little more clear to you. Yeah. So this can be written as what? This can be written as dy by dt upon dx by dt. Yes, this is how you can express this. So dy by dt will be 2 upon 2t. So this will be 1 by t for this case. Yes, is that clear, every one of you? So now the derivative of a homogeneous function of degree n represents n straight lines passing through the origin. Yes, if y is equals to ms, then dy by dx is equals to y by x is equals to m is equals to constant. Hence d square y upon dx square is equals to 0. The derivative of an inverse function, I think you have studied this, that is y is equals to fx and x is equals to gy, then gx can be represented as the inverse of fx, yes, and f of gx is equals to x, yes. And successive differentiation, that is you are taking derivative by derivative, that is we have studied about the first and the second derivative. Yes, so the determinant of a and the derivative of a determinant can also be written in the very same way. That is what you will do. First of all, you will differentiate the first row keeping the other two rows constant, then you will differentiate the second row while keeping the first and the third row constant, and then you will differentiate the third row while keeping the first and the second row constant, and then you will get a very final answer for that. Yes, is that clear? And now we'll take the derivative of the inverse trigonometric functions. So here we have to make some sort of substitutes. That is, for the terms in the form of x square or under root x square plus a square, you have to make sure that you have to always put x is equals to a tan theta. For the terms of the form x square minus a square or under root x square minus a square, always make sure to put x is equals to a sec theta or a cosec theta. For the terms of the form a square minus x square or under root a square minus x square, make sure to put x is equals to a sin theta or a cos theta for both the cases. Yes, and similarly for under root a plus x and a minus x, then put x is equals to a cos theta and you will be getting your answers for that. And you can follow the same approach, that is for the substitution of under root of x minus a, b minus x, you will have to put x is equals to a square plus b sine square theta. Is that clear? So now this was about the mind map series for Merchant Navy IMU-CET entrance exams. Okay, so hopefully everything was clear to you guys. I tried my best in explaining to you guys, and hopefully some good content has come in on the way for you guys from the side of Marine Edge. Where